Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which finds the largest three elements in a binary tree. First, let us take an example. We can simply take three variables first, second, third to store the first largest, second largest, third largest respectively and perform pre-order traversal, and each time we will update the elements accordingly. Now let us see the algorithm. Let us also have a sample tree to test our algorithm. We pass the root node, which is 15, along with three variables first, second and third, which are initialized to 0. Since root is not null, we check if root is greater than first. As it is true, we set third to second, second to first and first to root. So first will be equal to 15. Now we pass the left child of 15, which is 10, using a call stack. So root will now point to 10. As root is not null, we check if root is greater than first. Since it is false, we go to the else if statement and check if root is greater than second and root is not equal to first. As this statement is satisfied, we set third to second and second to root's data. Again, we pass the left child of 10, which is null. As root points to null, we return to the previous call. Now we pass the right child of 10, which is 12. So root will point to 12. As root is not null, we check if root is greater than first. Since it is false, we go to the else if part and check if root is greater than second and root is not equal to first. As it is true, we set third to second, second to root's data. So third will be 10 and second will be 12. The left and right child of 12 are both null, hence we return and finish execution for node 12. Execution for node 10 is also over. Execution for root 15 is resumed and now we pass the right child of 15, which is 20. So root will point to 20. As root's data is greater than first, we set third to second, second to first and first to root's data. Next, we pass the left child of 20, which is 16. Hence, root points to 16. Now, the else if statement is satisfied as root's data is greater than second and root's data is not equal to first. So we set third to second and second to root's data. The left and right child of 16 are null. So we return and finish execution for node 16. Execution for node 20 is resumed and now we pass the right child of 20, which is null. So root points to null. As root is null, we return to the previous call and finish execution for node 20. Execution for node 15 is also over and we have the final first, second and third largest elements in variables first, second and third respectively. Now let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.